part of the tech stack now also includes being goated at crafting the right instruction. I'd be curious to see what these courses or these certificates actually look like. If someone came to me, frankly, and said, hey, Rich, check it out. I have a couple years of coding experience, but most importantly, OpenAI thinks I'm pretty good at prompt engineering. I feel like it's almost a detractor for me, you know?
Speaking patterns break the code, pre-trained pod.
And welcome back to the Pre-Trained Pod, where AI scientists talk shop and talk shit. I'm Pierce Freeman. I've built and sold multiple AI startups in San Francisco.
Hey guys, this is Rich. I'm a postdoctoral research fellow at the University of Cambridge, where I research small language models.
Richard, I heard you threw a hell of a dinner party this weekend.
Oh my lord, dude. It's quite the blast. It feels like there's a good group of American expats now in London. And for whatever reason, it's been 4 years that I've been here. And 80% of my friends are these American expats, for better or worse. I don't know how that's happened. It feels like in a city like London, it should be pretty easy to make friends who aren't American. And I do have some, but it was just interesting to see at this dinner party, all of us just have American accents here.
Yeah. You're like where
all
are
of
we
us
again?
Expats just together
Could be
in a
New York
room.
City, Florida,
Exactly.
San Francisco.
Exactly.
Well, Richard, we have a very fun show today. We got a lot to talk about, a lot more papers than usual. I think it's about time that we spend a news segment talking about some of the cutting edge R&D coming out of academia. So on the docket for today, we have trying to quantify the amount of AI content online, the cost breakdown of embedding models, OpenAI's certification program, AWS launches a new agent builder, and maybe LLMs can get brain rot too. We can get started on the question of trying to quantify the AI slop factor online. This is kind of a phrase that comes from the idea that so much of the content that's online right now is actually AI originated. As it becomes easier and cheaper to write AI content or make AI videos, there's no surprise, perhaps, that the prevalence of that online is going to increase. But exactly how much is AI generated versus human generated, I think is still an open question. So this company called Graphite tried to do an analysis on this as to how much AI is really online these days. And their methodology here was to take Common Crawl, which is this corpus, basically an open Google index, except any researcher or any data scientist can interact with it. They randomly sampled 65,000 articles across different time periods, so all the way back to, I think, 2023, and said, given these, let's try to classify these articles that appeared in the wild as AI written versus non-AI written, and then plot that over time. And they discovered that the amount of AI content online peaked in November 2024. And since then, it has stayed roughly constant in a ratio where 50% of content online is AI generated and 50% is still human written.
This is of all content online. Half of it is written
all
by
articles
AI.
online. So if you see like a blog post online or you see some SEO optimized article, that is the content that they're really talking about here.
Wow, that's terrifying. I mean, that's surprising almost.
Yeah. Do you feel like that's a higher ratio than you were expecting or a lower ratio than you were expecting?
I think that's higher than I was expecting. I would have said maybe like 20% or 10%. Just because you got to think, I mean, all of Wikipedia was written largely before AI, right? All of the books, by and large, are still written by humans. Stack Overflow, like all the internet that existed before 2020, that was all human written. So the fact that it's 50-50 already in the span of 5 years, I think that's pretty crazy. Don't you think?
I don't know if I find it that surprising. I mean, I feel like so much of the content online is financed under marketing budgets because people want to get their own products recognized online.
You think they're ads mostly?
I think they're borderline ads, or at least like SEO optimized articles that are intended for the purpose of increasing that site's domain reputation. Because the game that Google has convinced companies to play over the course of the last 15 years has been that they will elevate you in search rankings if you have more content that is relevant to what people are searching for, right? So the game that you want to play as a company that's selling some product is to map out all the vertical or horizontal space that you operate in as a business, and then write content for that given vertical. With the idea basically being, if you can encourage people that you know or you suspect to be in your target persona will interact with this content, it's better for you to write that content, give people the brand awareness that your company exists in the first place while answering their question. And then people, some fraction of the time, will click through, discover your product, especially if it's a solution to the problem that they're searching for. So it's been this flywheel that has allowed Google to get better search results and the internet to become more populated because companies are financially incentivized to write content that helps people so that they land on their site and then end up buying their product. That's been the pitch over time. I think LLMs are changing that as people use them increasingly for content discovery.
Does this also include transcriptions of videos? Because I could imagine that more and more videos are being produced by AI compared to text.
That's a good question. It does not. So they specifically filtered for pages that have an article, like semantic header.
Okay. I see.
So it indicates that that page contains some article, which is another nitpick of this methodology. There are a lot of articles online that are valuable content that don't necessarily have that article header. So you can maybe figure point a little bit as to like the scientific methodology here. But if we take that ratio as roughly fixed, the thing that I thought was most interesting was the stagnation over time of remaining at a roughly 50% blend. And you don't see more AI content being pumped now than a year ago. The last 12 months, kind of since ChatGPT really took the world by storm, have been more or less the same.
Well, it's relative to the amount of human generated content, right? So if humans are just generating more content, but AI is also generating more content, you would still say that 50-50 ratio.
That's
Do
true.
you think it's possible that more people are just releasing things onto the internet now?
I don't think so, at least in terms of text articles are concerned. I think in terms of videos, absolutely. I mean, you see this exponential factor of the amount of content that's produced every day now is more than the entire amount of content that was produced on the internet in like 2005. There's a really
we're doing
obvious,
it too, you know?
Yeah, totally. We didn't have a podcast back in 2005.
Exactly.
So I think that ratio to me speaks to maybe people have just realized that AI writing isn't achieving their own objectives. My own experience here is I've worked with some of these SEO shops to try to increase our own domain reputations. And some of these shops have used AI extensively. Some of them have not used AI at all. And almost to a T, the articles that were written by people perform way better in SEO search results than the ones that are written by AI. I think in part because Google's kind of gotten wise to this whole game and have their own classifiers running on pages that are written to try to suss out, is this AI written? Is this written by a human being? Is it additive, like in some information theory sense? Does this actually increase the entire knowledge that Google indexed?
It's a game of cat and mouse, isn't it? It's like as AIs get better, they get better at fooling AIs that detect if the content was written with AI. And then those are going to get better. And then it's like a self-fulfilling prophecy that these two things are always going to be competing against each other.
I guess that's kind of an interesting point. This research fundamentally hinges on this classifier, right?
Exactly. The classifier for is this AI, is this not AI, right?
Yeah. And good enough AI, you hope to approximate exactly what a human would do. Like that's the entirety of what we're training these systems to do with minimizing perplexity. So if you really fool the classifiers, both on Google's and in this third-party metric, then you kind of screw up the ratio. It might be counting AI written works in the human bucket, if you will, which is not really what we want.
This is a really interesting study, and I think this has to be done quarterly or maybe semi-annually for this to be interesting. I'd love to see the trends in the next 15 years.
Yeah, so would I. I mean, I think if what we're seeing in the AI slop in other areas, my guess is it's going to keep ratcheting up and up as these systems get better, so long as they're able to fulfill the business objectives of we're able to write this article, get some SEO boost. I think the biggest thing that will discourage this, incidentally, is that people are increasingly optimizing for showing up in generative AI search results versus in conventional information retrieval search results. And in that game, I'm not really sure the lift that AI articles will give you, right? It's not really a volume game. It's almost more of an authority game of how many references to your own product can you stuff into ChatGPT or Claude's pre-processing layer. That almost to me is more important.
What you might want to do if you're trying to get Claude 5 or Claude 6 in the future to reference you, Pierce Freeman, or me, Richard Deal Martinez, in the training data, is to write a bunch of articles with a relatively simple language where the model can get fairly low perplexity on that data and hope that by doing so, the model is basically learning to encode the name Pierce Freeman and Richard Deal Martinez as like a low perplexity or easily predictable thing. You know what I mean? I imagine that there's little tricks like that people are working on. And there probably might even be like lines of research that are looking at how do you do this? How do you secretly cache your name into a data set, a pre-trained data set? I mean, I think we talked about that last time on last show.
Almost with the pseudo tokens.
With the pseudo tokens, exactly. Yeah, it's very similar.
Well, maybe we'll get some Pierce Freeman, Richard Deal Martinez pseudo tokens, and we'll try them out for
exactly.
see if it generates content with us. There was this other post that was in a similar empirical vein, trying to quantify how embeddings are so cheap. So the embeddings that we're specifically talking about here are when you feed in some long passage of text, like a paragraph or a book, and it just gives you out the numerical representation of what that means. We think of it like modeling the semantics of the given text. Within this blog post, it's really getting at the question of why these models are so damn cheap. And in comparison to generative text models that actually give you some text as output, they're outrageously cheap. You can tokenize or embed the full quantity of Wikipedia for something like $650. Or if you ask an LLM to do any kind of predictive inference on that, it's going to be in the thousands and tens of thousands. Like, it's going to be just so much more money. This article is positing that the reason why is because there's a race to the bottom in terms of pricing, because these models effectively do the same thing, have similar accuracy scores among numerical benchmarks, and there's not really the same kind of vibe check that we're able to give to these models as we can with some of the LLM architectures. Because
Right.
the only way that we can benchmark numerical outputs that are uninterpretable to people is try to use them to do downstream things. So, Richard, what's your experience with embedding models, period? And then what's your response to this finding or hypothesis that maybe embeddings actually are a carve out of this overall generative AI landscape, where the margins just don't exist because this is almost like a widget-based good where it's completely identical among the entire market and you can't have by firm differentiation?
Yeah, that's interesting. I mean, look, I think you're going to disagree with me on this, but in the field of academia, at least, to me, it's always felt like embedding models are on the out. This was a really interesting line of research maybe 5, 10 years ago when people were looking at information retrieval, sort of very simple classification tasks. I think researchers aren't as interested in embedding models anymore. I mean, I hate to say it, but it almost feels like a solved problem to a certain extent. Now, I know you're going to disagree with me because I think in practice and industry, a lot of people are still using embedding models for a lot of things, right? It just so happens that academically, these use cases aren't as interesting as they used to be. In part because we have all these more interesting tools now, like generative models, state space models, different types of reinforcement learning, post trading. All that's more interesting than these embedding models.
Can you maybe touch on why embedding models are different architecturally than their equivalent LLM, like generative models?
So the idea used to be that the purpose of a language model was to extract embeddings from the model. So you would train some sort of a model that would learn a representation for all of the words that have ever been uttered by humans. And once you have this representation of all the words that humans use, you can use those as basically inputs to some tertiary model that is trained to perform some task. So let's say that we train a model that has a perfect understanding of all these words, gives us embeddings, then we can use those embeddings for instance, predicting a word in an article we talk about XYZ topic, right? So this would be like an information extraction system. Or we can use those embeddings to do a question answering task. We're given some question, given a passage, we can look up in the passage where the question is answered. So these were the primary tool of machine learning scientists and NLP scientists up until I'd say 2018, 2019. Then BERT comes out, transformers come out, these generative models come out. And all of a sudden, it turns out that you don't even need to really care about the embedding so much. You can have the model you actually train, spit out to you different solutions to tasks that you might be interested in. So now, rather than taking embeddings out of a model and piping those into a third model to solve some task, you can just use the same model you used to pre-train on for the given task that you're interested in. So that's why embedding models, these models that give you basically these representations of words, aren't as interesting anymore. That said, they are pretty fast. So in general, learning an embedding model is less complicated than learning a generative model. So it's much easier to learn a representation for tokens than it is to have a model that can generate tokens on the fly. Right? In some sense, it's almost like one task, this generation of embeddings, is like being able to encode information into a token. And then the other model, the generative model, has to then also do that and generate text in addition to that. It's a more complicated task. So typically, what you can do with a generative model is, in some sense, you can extract embeddings from the generative model directly. People typically don't do that because you would rather use the generative model to perform some task, right? But you could in theory. But if you only care about embeddings, if you don't actually care about generation, then you can just train a much smaller model to create embeddings for you. You don't need a generative model to do that task. And folks back in the day were using different types of architectures. Frankly, they all are transformers. It's just a function of what loss do you basically use to train these models? A loss function that gives you a generative model is much more complicated than a loss function that can give you an embedding model. In some sense, getting the loss function to generate an embedding model is a much simpler task that you train your model on. But the architecture of both an embedding model and a generative model, the actual core, what it looks like, is roughly the same. It's just about how you train these things, where generative models are more complicated. Did I answer your question?
Yeah. So I think the TLDR is that it's both much harder to train a generative model that outputs text, and that the inference time for an embedding only model is much faster because you only have to do one forward pass and you don't have this auto-regressive nature of having to loop over
Yeah.
tokens, generate one, sample that, feed in the model, generate the next token, and so on and so forth. You're just encoding it and then generating a one-shot output of this is the embedding vector that we're talking about.
Think about it this way, Pierce. Let's say when you were learning French or Spanish, you were basically training an embedding model for yourself. That given a new word in Spanish, you were trying to basically learn what the hell does this mean, right? A word you've never learned before, you learn some embedding, some representation for what that word is. And typically you're gonna map that word to an English word that you already know, right? So if someone says perro in Spanish, you're gonna be like, oh, that's dog, right, in English. And then your embedding model in your brain is going to basically map these two concepts to the same embedding, the same representation. Now, that, from your experience, I'm assuming, is an easier task than actually having to generate a sentence, a fluent sentence in Spanish, right? It's easier
Oh
to
yeah,
recognize
absolutely.
words in Spanish than it is to generate. That's exactly the same thing that's happening here with models. An embedding model is almost like a model that can understand things, but doesn't know how to speak. A model that speaks has to both understand stuff and then also generate the text in a coherent way. It's a harder task. And that's what whenever we learn a language, we firsthand have experience with this, right? I think that's a pretty good analogy to encapsulate the difference between these two things.
Yeah, totally. I think the other factor here too, specifically what's talking about of the cost of embedding these tokens has dropped so precipitously. I think one reason why is again just because of the forward pass. Like it requires like fewer flops in total to do this than to do something else, and because GPUs cost so much and are in such limited demand, things that use more flops are going to be more expensive. It's the same reason why Opus costs more than Sonnet, which costs more than Haiku. They're just bigger models. Like they take more flops to deliver the same kind of task output. So I think that is like materially why. But I think the other part of it too is where we use these in practice in industry. And I think one of the reasons why they still are so applicable in industry in a way that they aren't really within cutting edge research is because most of the systems that we end up using these things for in industry, we want some provenance, which is really clear of where this data came from, right? You can imagine if some company has all their documents, like every email that was ever sent, every contract, and you want an LLM to be able to synthesize some data based off of that, right? So the way a human would do it would be to say, okay, I'm going to find the most relevant data points. I'm going to find the most relevant documents. I'm going to read them. I'm going to then summarize what I've read and then maybe make some extrapolation based on that, right? We've modeled these agentic systems in basically the same way, where we say the first thing that we want to do is to go out and get the documents. That's the R part of RAG. So retrieval, augment, generate.
Retrieval. Yeah, exactly.
You're trying to get these things, and then you're trying to augment them, do something more, and then you're trying to generate some text output. The R, I think embeddings have really found this product market fit because classic information retrieval just sucks for things like this. Like you need to get the phrasing explicitly right of are these key phrases within this overall document.
Oh, you're saying like pre-ML basically.
Pre ML or at least like pre embeddings. Yeah. Pre parameterized
the
models
prehistoric
that are
days.
able to
Yeah.
yeah. Which is actually still how most information retrieval systems in industry work. If you spin up an Elasticsearch cluster, the assumption is you are doing a keyword-based search and not doing a semantic-based search. To do any kind of semantic search, you then get into vector land, and it's seen as two kind of separate things for most people. So anyway, when you're doing that by hand, you're actually doing searches yourself. I think that kind of aligns with what humans more naturally expect to see in their own search results. If you're on Google and you're searching a key phrase and you see all the results that come back as having that key phrase, that's scored by people as being good. That's like what we expect. We like that. The system's actually going out and retrieving us documents that aligns to that key phrase. With vectors, they're often results that people don't really expect themselves because you can't point as easily to here's the key phrase in this document that aligned with what you're talking about. But with a good enough embedding model, the semantics should be similar. So it basically reduces the burden of crafting the perfect query, and you'll still be able to get the same documents if they touch on the same kind of subjects. So I think the reason why embedding models are useful in that regard is because we're limited in the context length that these models can extrapolate over. So we have to pare down the documents that we give them in some way. And the best way to do that in a way that has the model crafting that query, getting documents back, and then acting upon them is to effectively use this vector search where we can compress this complex and like otherwise verbose text into some like really neat representation and then only act on that intermediary representation to get the outputs that we then pass to the model. I think that's why people like it. It's a question of like computational
Yeah,
efficiency
I think you're right.
before we have to expend the effort to generate things as like the final downstream task.
And that totally makes sense. I think the issue that I run into with embedding models is that oftentimes you don't just want an embedding for a word or a token, which is typically what an embedding model gives you. Typically, when I've worked with embedding models, I kind of want an embedding for a whole document or a whole book or a whole chapter or something that lets me do a retrieval at a very high semantic level where I can say, I want all articles that are like this one, or I want all research papers that are roughly talk about this subject. And for those, if you have an embedding model, you have to do some sort of trickery basically, right? To learn a representation for the whole document. Do you sum up all of the individual embeddings? You learn some other network that kind of combines them in some weighted distribution? Do you learn an embedding model at the document level? Right? These are all open questions. And at that point, I would almost rather just have a generative model give me the answer. This is like, in some sense, like how LLMs nowadays, like their power is almost that you can feed them in a question, and then the output isn't like all set of documents. It's really just typically like the highest likelihood document that is most relevant to your query, right? Does the search for you, and it encodes an embedding model as part of the generative process. But regardless, they're interesting research items, I think. I think there's a lot of unsolved problems with embedding models.
Yeah, incidentally though, I think the unsolved research is more on the chunking side of things. It's almost like what do you give to the embedding system to get the embedding? Because exactly what you just discussed, the contract that these models have to you as like an end user developer is you give them some text string and they give you an output. And that's literally their only contract, right? So the few different ways that I've seen people do this in practice is to say our chunking strategy is going to be on a per paragraph level. So if we have some really long document or email that has a ton of different paragraphs, each paragraph might mean something different or be discussing different topics. So we would much rather learn a different embedding for each of those paragraphs and then search through those independently. So if one paragraph triggers some topic, it's retrieved. And then if other ones don't, that doesn't really matter as much. The other way to do it is to say at a per sentence level. The other way is to say at the whole document level. And I think that still gets to a little bit of, it's almost the equivalent of like context engineering, where depending on the problem that you're trying to solve, you might want to embed those differently. And what you just said almost makes me wonder whether or not some future end state of compute becomes really cheap, but we still want this emergent property of having some cached single vector embedding that we can retrieve in an information retrieval setting to then do something with. Might be we pass the entire document to a model. That model gives us a series of embeddings, almost 10 or 15, or maybe it's dynamic based upon the input to say, here are all of the different topics that you're touching on here. We're not going to force a single compression into one vector, but instead part of the task that we're trying to learn is how do we globally optimize the vectors that are outputted in order to then just be stuffed in some cached database bank somewhere and then retrieved. That to me is pretty interesting, but that gets a little bit less to like, how do you train an arbitrary model to take in text and get an embedding output? And more, how do we model this entire pipeline flow of we want the semantics captured in embeddings because those have nice numerical properties.
Yeah, it's an engineering problem at that point.
Well, don't you think that would be an ML research problem? If we in fact are trying to encourage architectures to choose the semantic output embeddings that we're giving it?
But you said you learn like 10 or 15 embeddings. I mean, that seems like a pretty big hyperparameter, right? Wouldn't you want to have a model that can cluster itself into all these different types of embeddings in some logical way, like a maybe some sort of like a hierarchical structure where it encodes at a high level, like the pragmatics of the document or the book or whatever it is you're embedding. And then at a syntactic level, you have different types of embedding. And then at a morpheme level, you have different types of embedding. And you have like these phonological embeddings. You can generate embeddings for so much stuff that it's hard to pick at what level do you stop or at what level do you stop chunking. To me, it seems like it's a frankly engineering problem where you need to pick the right hyperparameters for how you want to chunk things, at what level of granularity do you want to embed things, how you group them together. I don't think there's a good answer for this. If you wanted to do this as a research problem, it would have to be a very empirical study where you run 1,000 different permutations. That seems like it would be a hassle to do. And frankly, I don't know if it's that interesting from an academic point of view. But I think from an industry point of view, it's definitely an interesting challenge. And I imagine people will keep working on this, even though we have great generative models.
There's certainly a lot of money to be had. I know someone who was going to start
sure.
a vector database company back in 2020 and decided not to. And I think he's been kicking himself ever since. Because,
Oh, yeah, I can imagine.
Yeah, Pinecone's worth a couple billion at this point. Moving on to our next topic of discussion, these OpenAI certificates. This was a blog post that they put out a couple weeks ago at this point, but we haven't yet talked about it on the pod. So there are basically two things here that they've announced but not quite implemented within their platform yet. So this is kind of a letter of intent for what they're planning on doing in the future. The first thing is launching a new jobs portal for people that know how to integrate AI into other companies. So the idea here would be to get a bunch of people who are AI aware, have interacted with these systems, know how to build them, and then companies or governments on the other end of the marketplace that are really looking for that cutting edge expertise, try to connect them together with AI. And then the other thing is expanding their existing education academy to give people certificates in these different topics. Versus right now, it's been largely self-serve. I think they're looking to make it more of a formal curriculum so that people can take an OpenAI certification to assess their capabilities within certain of these generative AI fields that are a little bit more applied. Like I said, neither of these have actually been released yet. So I was thinking that maybe we could opine on both this announcement and what we would like these different platforms to look like if we were sitting in the PM seat. Opine away, brother.
The first thing I'll say is that I think there's some clear parallels here to what other existing companies have done for the last like 10, 15 years. Google Cloud has had their certificate program for a long time. A lot of these like front end platforms will have their certificates. It's at least in the web dev space, this isn't anything new. And I imagine a lot of folks that are using these tools are using them for web dev. So it kind of fits into that family of wanting to have certificates for all these different things to prove to employers that you have a deep tech stack. And I guess now part of that tech stack is not just being able to use things like Node and React and all these tools that people used back in the day. Part of that tech stack now also includes being goated at crafting the right instruction. I guess prompt engineering has become part of the tech stack. And I think that's interesting. I'd be curious to see what these courses or these certificates actually look like and to what extent people actually respect them or take them seriously going forward. If someone came to me, frankly, and said, "Hey, Rich, check it out. I have a couple years of coding experience, but most importantly, OpenAI thinks I'm pretty good at prompt engineering." I feel like it's almost a detractor for me. At least in 2025, with my maybe my boomer hat on and my outdated engineering sort of like legacy perspective on things, I don't think it's great that you're really, really good at prompt engineering. I would much rather you have spent a year or two reviewing fundamentals of systems architecture and how to design good code that is theoretically interesting and has these nice properties. So it's almost a detraction to be able to say, I've spent 2 months perfecting my prompt engineering skills. To me, that doesn't really speak highly of your engineering skills. I would almost be confused why you're including this in your resume.
Mm-hmm.
Now, that said, I was born and I grew up in the early days of AI. I could see myself in 30, 40 years looking back at this and saying, "Oh my God, I can't believe I ever said that." Right? There's now these wizards that are really good at prompt engineering, and these guys are the 10x engineers at all these companies.
Yeah,
now.
they're like the AI whisperers.
I could see that being totally true. And it's not false to say that some people are better than others at using these tools. That's absolutely true. In fact, I think you are pretty good at using these tools. You have a whole set of blog posts where you've written about how to craft a good structured query to your model and receive a certain structured output. and the importance of including like test cases in your prompt. All these things.
Hey, I didn't know you read my blog, buddy. That's
Hey,
flattering.
dude, I read it all the time. And you're probably right. I mean, these things are probably important for models, and it's hard to measure how much better you are at prompt engineering than just your regular Joe, and how much that has a an impact on your ability to push out code. I'm sure it's some order of magnitude more. I don't know how much that is, but at some point, as it becomes more evident that the better you are at prompt engineering, the better you are at pushing out code, people will start taking this more seriously. And I could see there actually being these courses being more valued in the sort of like zeitgeist of how companies recruit folks. So far, I think like as of today, I don't think that I would look at this certificate as a very important thing, but I acknowledge the fact that in a couple of years I might have to take back what I just said and acknowledge the fact that this was actually very important and that these courses are the future.
Well, hey, date stamp that for October 21st, 2025 for that take.
Yeah.
I think I'm with you, man. I mean, I'll put it this way. I think these certificates are well and good for what they teach. I don't know if the certificate themselves really holds that much meaning or value when I see them out in the wild. Because I've looked at a ton of resumes over the years, and I always index far more, order of magnitude or more, on what someone has done in their open source contributions or in their past company projects than I have on these degrees or these certifications that people have. Because I think these courses, they'll give you some pet projects, but I think with both engineering as well as with AI, where the rubber really meets the road is on the applied implementation side of thing. You know what I mean? It's can you get unstuck in engineering is a skill that won't be taught in these courses because the courses are giving you whatever the task is on more or less a silver platter. They're like walking you through linearly. It's very academic. This is what this thing is. This is where you use it. Maybe this is a project that showcases how you can use it in practice. That's relatively little of what engineering is in practice. It's much more, can I actually construct a system and think through the different trade-offs? Very hard to teach without the lived experience of having done that thing. So if you are an AI practitioner that works for some company doing this, that's fantastic. A certification that shows that you're academically familiar with these concepts, I honestly think people would probably be better off looking at YouTube and then just self-studying different material, going from maybe look at Andre Karpathy's videos of him implementing an LLM from scratch. That might not
Oh
be the
yeah.
kind of
Those are
work
great.
you're doing
Yep.
day to day. Yeah, great videos, also free. That doesn't really teach you the applied skills necessarily, but I think it gives you a working vocabulary of the kind of things that engineers consider themselves. And because of where we are in this overall landscape, just becoming familiar with the way that people think through, okay, what is memory? How is that actually implemented behind the scenes? What are the trade-offs? What can and can't this do based on how they're
Yeah.
implemented?
The real
What is
fundamentals.
temperature? Yeah,
Yep.
totally. Listening to the pre-trained pod. I think all of that stuff that's a little bit adjacent to a curriculum will probably give you more mileage. And I put a lot more stock into courses
I
that
would
come from academia, like looking at an MIT course or looking at a Stanford course that teaches the lower levels than I would a
yeah.
certification at some of these corporate
Yeah.
classes, which obviously have separate objectives.
I think what you said about that feeling of being stuck is something that I'm worried future engineers will never get to experience. I think when I look back at the last 10, 15 years of my engineering experience, my coursework, my projects, the thing that's taught me the most is frankly just the resilience to be able to get myself unstuck from something. Like that feeling of just utter helplessness. It's 11 p.m. You have your assignment due at 6 a.m. and you're just so stuck. Like you don't even know what to Google, right? So you don't even know where to start. And when you do Google something, you're just getting all the wrong Substack answers. That feeling, I think, isn't going to exist anymore, or not to the same extent, or not as frequently as it used to 5, 10 years ago. Even like 3, 4 years ago, I remember working on projects and literally not even knowing where to begin. There's absolutely no blueprint. You just have to talk to people, really take walks in the park, think and think and think some more, journal, and then finally maybe you'll get some eureka moment. That to me is frankly what engineering is. And since I've started using these tools and I've started working on other projects, I don't think I've ever felt stuck in the same way that I used to anymore. I don't know what your experience is, but I think with Cursor, if I'm stuck, it's so easy to just get some nugget of information that will lead you down the right direction, or that will at least maybe lead you down some direction. Maybe it's not the right one. And I'm worried that in the future, as students are now learning how to code, they're going to be using these tools and never get to experience that feeling of just utter desperation that used to be so commonplace.
That's such a boomer take, dude. It's like we used to walk uphill both ways. We used to debug these systems from scratch.
But that is what CS is to me. It's just this feeling of having some incredibly difficult problem, not even knowing where to start, slowly making progress, getting this eureka moment, then spending like 20 hours in like a flow state, getting 80% of the way done with a project, and then debugging. Like these are like just these steps that are part of building something. Now it feels like you never get that first step. You always have a solution from the get-go. And you basically almost fast forward to the very last step where you're just debugging stuff.
Yeah.
But you never really have to force yourself to learn something. Like the solution is just always given to you. Maybe it's a boomer take. I think there's something to it. I think like learning resilience and like tools for how to get yourself unstuck, how to talk to people, what questions to ask. I think these are genuinely good things, even if we have the right answer.
Well, I think that's
it's
the
tricky,
core
man.
skill that extends across certifications or across degree programs. Like even if you pivot outside of doing ML research, I feel like that core skill is the same for basically any career, or like basically true for any field of study. It's the act of getting unstuck. I think it's the act of surveying a lot of information and then trying to ascertain what part of this is actually contextually relevant. I don't know. Yeah, it's obviously being able to unstuck yourself faster is good for labor productivity. Probably isn't great for building up those neurons of resilience to be able to do that yourself, which is maybe not so good. And I think in both cases, I really boil down to I think it is a useful exercise whenever you take some course or whenever you do some certification to try to take whatever core learning you've done there and spin it off into your own project and try to minimize the use of Cursor as much as possible when you're actually doing the implementing. Or tab complete's fine. Maybe just don't turn to the agent. I've recently had this workflow where I'll have Cursor, which has AI suggestions enabled, but then I'll also have Zed sitting side by side. And I try to at least a couple days a week open up Zed and implement this new feature by hand. So I'm not even tempted by the Cursor agent or autocomplete.
Don't let the temptation overcome you, dude.
Because it is tempting. You know, one more pull on the slot machine, you're finally going to hit the reward. That's literally the dopamine feedback loop that you get with the agent sometimes, where you prompt the first time, it's close, but not quite right. So then you're like, well, might as well prompt it again. See if it does something better the second time. And then you can get into a loop where you've done that 5 times and just wasted 45 minutes.
Yeah, you just feel like you're like brain rotting yourself too.
Yeah,
you know?
You're brain rotting yourself, brain rotting your code base. You have 20 new files that Chris has created over those cycles. So taking a step back, I think these certifications are still TBD. The devil's in the details of exactly what they teach, what they're trying to get people to do. I'm interested in them a little bit more for government folks, quite honestly, because OpenAI has such a big government partnership, and you can see a lot of their recent material is like ChatGPT and Government 101 kind of a vibe. I think upskilling people that make policy who are very much not engineers to get to know some of these internals and how these systems work is super critical, because we just need more people thinking about what are the societal ramifications of using this technology. And I think the best people to do that are people probably in the public sector versus us pontificating from the private space.
Yeah, 100%. Brave new world, dude.
It's a brave new world. Get educated, kids. That's what we're saying. Okay, Richard. Amazon announced their Bedrock Agent Core this past week. This is a most direct competitor to the agent framework that OpenAI released a few months ago, or at least that's how I see it. Maybe an open source competitor to things like LangChain and Llama Index. You see Amazon already acting as an aggregator in the LLM space. Like they have Bedrock, which hosts these different model architectures. You can proxy into OpenAI's, Claude's, Gemini's. It's a one-stop shop, very much kind of like OpenRouter. They're starting a layer of functionality on top of it that encapsulates more of the business process, like compute session isolation, memory, code access, browser use, almost like tools that you can call. There's a gateway that lets you expose these different MCPs and Amazon internal services. The scope here seems absolutely gigantic. And they seem, at least to me, to be trying to compete with some of these startups that are capturing a little bit of this market share at different parts of the stack. They're trying to just own the entire enchilada with its agent core. Do you think fundamentally this is the strategy that we're headed to in the future, where there will be some of these cloud vendors that are more turnkey, like, hey, come to us, any agent that you want, we'll support, we have you, cut down development time, but at the risk of you're generalizing, so you're necessarily losing specificity? Or it's going to look more like the world that we seem to be in now, where we have one service that's Open Router, which is just trying to route to different vendors. We have one service or a couple of them like Pinecone, which is going to be your vector database, or super memory for your memory layer. Do you feel like there are fundamental qualities of the ML marketplace that lend themselves to centralization, or that inherently are a little bit better for the distributed services that we have right now?
Let me ask you a question, because this is honestly your field of expertise. My sense to this is that we're going to hit a point where compute's going to be fast. It's going to be almost instantaneous. The thing that's always going to bottleneck us is going to be, frankly, the speed of light, and the fact that we're still transporting things over these cables that have to communicate with each other and that have to use these internet protocols to interact. And whenever you have distributed microservices and different tooling, I think you're going to hit a wall very quickly where you're going to hamstring yourself by the fact that you have to always rely on the internet to send packets back and forth before you can actually get the output of your application. Like, having to communicate between different tools feels like eventually that has to be the bottleneck, that we only have so much bandwidth on the internet that we're not going to be able to build out
Wow.
these fiber optic cables fast enough.
A bandwidth limitation.
I mean, thinking forward the next 10, 20 years, I just feel like the models have always gotten faster. Everything is getting faster. Compute and inference, especially, is going to feel instantaneous in the future. Already, we're seeing models that are able to produce the order of 100 tokens per second. I mean, some of these demos are insane. At that point, isn't the bottleneck always just going to be bandwidth, frankly, or just the inability to send enough data through the internet? Wouldn't it be better just to have one big service at that point?
I mean, I think as long as we're just sending text data through the internet, I feel like our existing pipes are probably big enough, because we've had to build them out in order to accommodate global utilization of 4G video streaming, that they're probably big enough to be able to accommodate any kind of text, no matter how prevalent these things get. I think the second that we're starting to talk about distributed training, of actually having to send like raw matrices over the wire across the open internet, if companies want to eventually do that, I think that gets a little bit dicey.
And I think that's more what I'm talking about.
I think the way that we seem to be orienting of this bifurcation, where we'll have a lot of small models that are probably distributed on edge that are pretty good, and big models that are hosted in these data centers, I think in the latter case, those data centers are just going to build their own backhaul. Like, Google's data centers are connected by Google's fiber optic cable, or at least fiber optic cable that is subcontracted out by Google. They're not really hosted on the public internet. Like, they're routing around separately. I think that's probably what you would need. Sure. Like, you would want to own your own pipes in that kind of a setting. I think my take here is a little bit like, if you're a company and you think that having an agent is in your core competency, like, you're really going to market as, I hate to say this because it's kind of a pejorative, but if you're a ChatGPT wrapper, right? Like, you're not developing your own models. You're just building functionality on top of them to then fulfill some business process. I think the things that you uniquely own, if not the model itself, is the business logic, like the know-how of exactly what you're trying to do, who's your target customer, and what problems do they have. You're trying to encode some of that knowledge into the model. And then the other thing that you have access to is, what exactly can this model do? Like, what tools can it call? What kind of data can it return? How can you craft the prompt, or like prompt interactions between different things? And I think that there's a lot of things in that second bucket of building the tools that I would want to own as a proprietary stack of my company doing this thing. Because if you own the code, you can just modify it more readily. Like, back when I was using SageMaker, which is their AWS ML kit for training models and doing like inference.
It's the worst,
models,
isn't it?
We were using this back at Globality, right? And we started off with this kind of sexy pitch. It was a little bit like this agent core where we have these turnkey things. It's really easy to train a new model, even some like cutting edge architectures. Just give us a CSV, train the model, right? And that's a pretty great pitch, especially for overextended data science teams. So they're like, oh, amazing. Okay, this sounds great. So you try that out and it works for a POC. But then the second that you want to modify more like knobs and dials or change the curriculum learning, it just doesn't give you any of that. So you're like, oh, well, okay. I guess now I have to re-implement what AWS just gave us for free into our own code and then use SageMaker by calling a Docker container to run that code and then to give us the output.
That sounds like a nightmare.
Right. So then now you're paying the AWS service fee and the SageMaker service fee, but all that it's doing is just running code that you yourself have written on their same GPU pods that you could then boot up in a non-SageMaker form. So anyway, we ended up switching over to just manually provisioning these GPUs because it was cheaper and like more flexible. But I kind of would be worried about that in this specific case. Like I'd be worried that because this is a relatively closed source hosting ecosystem that you're locking yourself into, that this field's moving so fast and there's such a core competency to be gained of if you really are owning the nuance of how these different things are called, or maybe in 6 months from now, there will be some derivation of memory that's solving the same problem, but is vastly different that AWS is just lagging on implementing on their end. You now are stuck where you're either going to re-implement this whole thing.
It lets you be more dynamic to do it yourself.
Yeah. I think that's my leaning, right? If you're a company that's like trying to really own this stuff and you see yourself as an AI company, I'm guessing the companies that are going to end up using this in practice are a lot more like the enterprise service clients that AWS serves, where it's really hard to source external contracts from these like smaller vendors. There's PII concerns with having this data within AWS's cloud. And they're trying to get those big companies to just use this to say, hey, you don't think of yourself as an AI company? That's totally fine. We don't want you to become one. But if someone on one of your teams says, hey, we think an agent can help us with X, Y, and Z, you can build that out with our turnkey tooling. And it won't be the best in the industry, but it'll be okay. You'll get the job done.
Yeah.
I see that being the case here. And in the macro, I'm a lot more enthusiastic, I think, at least at the current moment, for piecing together the best in class solutions from across the entire market and letting your code be the unique layer of exactly how these things are interacting with themselves than I do a full turnkey solution, especially one that doesn't actually host the models themselves, because there's only so much control that AWS has here.
Yeah, it gives you more flexibility. It's even more fun for you to develop, right? You have access to everything.
Yeah, which
so that
matters
makes
too.
a lot of sense.
Enjoyment is, I think, is part of having a really good outcome. Okay, Richard, our last topic of the day, talking about LLM training. This one came out of Texas A&M. It's a paper questioning whether or not LLMs, much like human beings, can acquire brain rot. So like brain rot being this, I think it was Oxford's word of the year last year or something, but it's all this content. It's just dumb. You're like scrolling through your TikTok feed. It's just brain rot. You look up 2 hours later and you realize you haven't really learned anything. You've just fed directly from the fire.
I think we're all unfortunately familiar with the experience. Yep.
Yeah. We all know that pretty intimately. So obviously that can happen with people looking up 2 hours later and realizing what happened here. Similar phenomenon can happen with LLMs themselves that are trained on a whole lot of kind of this brain rot adjacent content. And specifically, if you expose an LLM to poor quality web data, that can cause lasting cognitive decline, even if you post-train it on good, high-quality data. So it's a little similar to what we were talking about.
Models, man.
I know. These poor models. They're just getting dumber and dumber by subjecting themselves to our kind of content. So anyway, Richard, I was hoping that maybe you could explain the slightly more technical takeaways here of how they set up their experimentation and then what the learnings were. And then also if you have any suggestions for how model practitioners at the big research labs can help ameliorate this kind of cognitive decline that's caused by just having to listen or read all of this garbage data.
There's a lot of interesting things that these researchers did in this paper. The very first thing that I found interesting is that they created this control set of just data of the internet. So just a raw sample of the internet. And then they also created a junk brain rotted version of the internet that basically used a bunch of heuristics to determine what is brain rot. One of the ones that's most interesting is almost this like anthropological or sociological study of Twitter data.
I love this one.
Yeah, where they basically created a bunch of heuristics to determine in Twitter data, can we predict when something's going to be brain rot? And feel free to chime in here. I think what they did is they looked at factors like the length of a tweet, the amount of replies, or like the conversation history of a tweet, and found that some of these things correlated very strongly with brain rot. I forget what factor correlated the strongest, but needless to say, the correlations were strong. So basically, it is possible to predict brain rot from just very simple heuristics.
It also makes me think that I should be scrolling a lot less on my X timeline.
Oh, for sure. For sure. Yeah. So after creating this data set of brain rot and normal data that also, frankly, contains a little bit of brain rot, they train these models and they find that models that are only trained on brain rot exhibited this weird behavior, which is that they tended to do something that they call thought skipping, which is when models would start basically truncating or skipping a sort of like chains of reasoning tokens. So they wouldn't really make logical sense. They would start talking about something and then jump to a completely different conclusion that is incongruous with what they just said. And this behavior, I'm assuming, arises naturally from the data distribution. So if you look at brain rot data, in that data itself, you see a lot of these illogical patterns occurring. And this is the exact pattern that this model is basically replicating, right? And so it learns to think illogically. Now, that in and of itself is somewhat interesting. The most interesting thing for me is that it's really hard to remedy this or basically recuperate some of the damage to make the model behave like it sort of would have had it been trained on normal data. There's typically the ways to do this, but in this case, they found that even with all their post-trading hackery and their tricks, they weren't able to get the model to unlearn its brain rot. Now, I will say I don't fully buy this. I think
Mm.
post training is very powerful, and I think you can do a lot of things with post training, especially if had they maybe continued to pre-train on some normal data, had they perhaps learned different adapters in the model that try to remove some of the brain rot. So many things you can try. So I wouldn't be surprised if some other paper shows that it is possible to remove the brain rot.
At the very least, it's non-trivial.
Exactly.
And
Exactly.
I mean, look, to be fair, maybe to how we train these models right now, you usually train any post-training process with a penalty for diverging too much, like a KL divergence, basically, on diverging too much from your pre-trained model, because you
That's
want it to
true.
keep the same properties of, the semantics or syntactic patterns that it was able to learn during pre-training. So it doesn't fully lose the kind of knowledge and shift over to an entirely different semantic space. So I don't know. I mean, there's a part of me that feels like if it landed on some optimal place within its pre-training data, you're obviously starting from that position, and the loss penalty that we put into place for deviating too much maybe is a part of the issue too,
It's
where
possible. Yeah.
especially for brain rot data, if you land in a bad regime, if you're just optimizing proximate to that bad regime, it's still going to be a bad regime.
Yeah, you'd have to take the model and restart it from almost like a different point so that it learns to converge to a slightly better point that isn't brain rotted, right? You'd have to almost like lift it out of this bad local minima that it finds itself in and hope that with some better data, you can force it down a better trajectory of learning. It's hard. It's really hard to do. And they show that it's actually surprisingly difficult. To me, this begs the question, should we be treating data curation as sort of like a first class training safety system where when we process the pre training data, when we filter out what do we want to train our model on, should we be thinking about that really from a sort of like a training safety perspective, like thinking about how do we remove brain rot data enough that the model doesn't become itself brain rotted, but not to the extent to which it's never seen brain rot data, because you also want your model to understand, hey, I'm seeing brain rot data now, and this is different from normal data. You see what I'm saying? There's all these nuances in how you train your model. I think there's a lot of questions here that people haven't been asking themselves because for the longest time it was understood that the more data, the better. But now that we have so much data, I think we have to reprioritize thinking about what data we feed our models and how do we filter out that data. We're sort of coming full circle to in the initial perspective, which was that training data was really important. That I think is going to be a key methodological step that hasn't really been fully solved yet, and that's going to be really important for models going forward.
Did you check out this appendix where it actually lists the ChatGPT prompt that it gave a model in order to try to classify these tweets as being junky or not junky?
Yeah, remind me again, what was it?
So it basically breaks down to here are the criterion that they define as junk. So things that seem obvious, like conspiracy theories, exaggerated claims, unsupported assertions, sensationalized headlines, extremely brief content. I almost wonder if that extremely brief content is one of the things that gives it this emergent property that's bad of not having the proper reasoning chains. Because if the overall tweet is really concise, then maybe there is some learned penalty for going too long. You could perhaps imagine that that's some property. But the funny thing that I thought here is they're counting as junk superficial lifestyle content that flaunts people's personal success, exotic vacations, perfect relationships, or idealized appearances.
Someone's gonna be like, "Hey, that's my content. That's not
junky. Right? Come on, it's the truth. I just live that way. It's perfect."
And for whatever reason, they also include if the author of the post was named Pierce Freeman. What's up with that, dude?
What's up with that? What's up with that? I'm trying to provide value. Come on.
Oh, but it's cool. I like these like sociological papers that kind of do something cool at the level of a language model, but then also give us some insight into like humans in general and how we can think about brain rot. These correlations that they discover between very simple heuristics of tweets and whether or not they're brain rot, I think were fascinating. I think that's actually more interesting than the language modeling that they did itself.
Yeah, totally. Because I mean, the downstream training pipelines, like that wasn't really the innovation here. And they did a spectrum that I thought was cool too, where like full junk, full control, and then different ratios, and then trying to see, okay, it's obvious that training just on junk is probably going to be bad, because some of the learned factoids and patterns are going to be incorrect from the junk alone. But at what point do you have that tipping point or like poison pill, like we were talking about last week, with when does it become a problem? At what ratio does it become an issue? And in practice, having an upper bound on that number will probably let us then enforce some amount of rigor on pre-processing of our pre-training pipeline to say, we need to make sure that that number is below this threshold, and then it's going to be okay. We'll be able to learn out the flaws within post-training. But if it's above this ratio and then tips through that point, that becomes problematic. I think getting a grounding on that number for each given model or model size is still a really open area of research. And I like this paper quite a bit.
I like that too. Yeah. They're doing good work out at Texas A&M.
Yeah.
Kudos to them. Yeah.
Kudos, go Longhorns. Is that right?
Go something like that.
Something
dude.
like that. Something like that.
Go Longhorns.
Don't tweet me.
That's right.
Okay, cool, Rich. Well, I think that more or less sums up the ML advancements of the past week.
Amazing. I think it does, man. Thanks for preparing that for us.
Absolutely. I anticipate we'll have a lot more news within the next 7 days.
Oh, for sure, man. Yeah.
We're just getting started. Well, till next time, buddy.
Hell yeah, buddy. All right, buddy. Talk to you soon. Bye.
Later.
So I walk into this like British Whole Foods, right? We go to the checkout, and as we're walking out, we see this guy in a massive trench coat. It's like dragging on the floor big. And these two guys who work there stop him and are like, sir, we saw on the CCTV, we think you took something. Can you show us your pockets?
Oh, reveal your trench coat.
And this guy's like, bro, leave me the frick alone. Like, this is my trench coat. I got nothing, dude. And they're like, no, sir. We have to see your trench coat. And he's like, dude, look, you can see my trench coat. I got nothing. Let me just walk out. This is harassment. I'm telling the truth. I can't believe you guys are doing this to me, right? And they're like, sir, just open up your trench coat, please. And then it'll all be over. He's like, fine. Opens up his trench coat. From like my POV, you could already see there's like a massive bulge on the inside of his trench coat. And they're like, sir, what's the bulge? And he's like, bro, there's nothing in there. It's just my trench coat, dude. It's just my trench coat. Leave me alone. And they're like, no, sir. We got to pull out whatever's in there. So finally, the guy comes, feels the lump, and he's like, sir, what is this? And he's like, it's nothing, man. Puts his hand into this guy's trench coat, pulls out like a 2-foot long lamb chop. All right, this thing's massive. It weighs like 15 pounds, maybe. Think like a Thanksgiving turkey, like maybe 3/4 of that.
I was thinking like a Renaissance fair, like little leg of lamb.
This thing's massive, dude. It's like a loin. You know what I mean? And he's like, I don't know, dude. I don't know anything about that, dude. But that's it, dude. I got nothing else. I don't know. You can keep that or whatever. But come on. All right,
I left a home with this, and now I'm here, and I still have my lamb chop. You're saying it's illegal for a man to walk around with a lamb chop?
And the guy's like, no, you got something else. Let me see what's in your right pocket. And he's like, dude, I got nothing in the right pocket. You guys just don't believe me. You guys are calling me a liar. I got nothing. The guy's like, dude, you just had a lamb chop in your pocket. Like,
It's true.
your credibility shot, dude. What's in your right pocket? I got nothing. Absolutely not. Opens up his right pocket. There's like an even bigger bulge in his right pocket. And they're like, sir, what's that? They reach in. It's like 30 onions, dude. Just come like tumbling out of his pocket. It was hilarious. It was like a
What's this man
cartoon,
planning on
straight up.
cooking, bro? Onion lamb chop? What's the
I mean, dude,
deal?
look, like times are tough, but it's cartoonish, dude. It's like this dude has a massive trench coat. It's like some Scooby-Doo shit, dude.
Totally.
Like there's just a lamb chop, like a whole lump of a lamb chop in his pocket, and then 30 onions in the other. It was ridiculous. It was
trench
comedic.
coat is like a clown car, bro. You
It literally
you
was.
think it's housing something, but then the more that you take out of it, the more stuff that comes.
Oh, totally. I mean, like, you know that this guy's done it before because clearly this trench coat works because there was a big lump, but then when he pulled out the thing that was causing the lump, I was like, holy crap. That actually is like pretty hidden. You know what I mean?
Yeah.
It's hard to like have 30 onions in your pocket without making like a little lump.
Totally.
So that was
He
crazy.
got
That was
overzealous.
kinda
If
crazy.
he only took 15 onions, he would have gotten away scotch-free. You wouldn't have even seen the lump.
Scotch-free, dude. Scotch-free. Exactly. So that was my story.
I like that.